Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have understood Mealy machines. And now in this lecture, that is Moore machines, we are going to understand the second type of finite automata with output, that is Moore machines. So the topic for this lecture is Moore machine. Let's get started. Moore machine is a type of finite state machine in which output depends only on the present state and not on the input symbol. It means that Moore machine is a type of finite state machine or finite automata with output in which output only depends on the present state. So this time output does not depend on the input symbol. In case of Mealy machines, output was dependent on present state as well as the current input symbol. But here, output only depends on the present state. That means only the present state will determine what is the output symbol. If you see in this diagram, the present state is associated with an output symbol. Q0 is associated with 0 and Q1 is associated with 1. That means only the present state has a connection with output symbol. In Mealy machines, here on the transition, we were having the output symbol connected to the input symbol. But here, input symbol has no relation with the output symbol. Output symbol is only determined by the present state. So, in case of Moore machine, present state and current input symbol will determine the next state, but only the present state will determine the output symbol. Next state is determined by the present state and input symbol. That is same as that of Mealy machine and DFA. But output is only determined by the present state, not by the input symbol. So I hope this definition is now clear to you. Now if I ask you what is the state label format, that means what is the format of writing a state? So the state label format is state/output. As you can see, we have written the state, then a slash, then the output symbol. So this is the state label format. And I have already explained you that in case of Moore machines, output is associated with the state. Output is associated with the state, not with the input symbol. So I hope a basic introduction of Moore machine is now clear to you. This is the transition diagram of Moore machine, and if I ask you to construct the transition table, it will look like this. So we have the present state column in which we will write the present states Q0 and Q1 like this. Q0 is the initial state and Q1 is a regular state. There is no final state in case of Moore machines also. Now, for the next state on input symbol A and B, we will fill these cells. So, Q0 on A. Q0 on A is giving us Q0 itself. So here we will write Q0. Q0 on B. Q0 on B is giving us Q1. So here we will write Q1. Now we have to write the output that is associated with Q0. So the output that is associated with the state Q0 is 0. So here we will write 0. Similarly for the state Q1 on input symbol A, Q1 on A is giving us Q1. So here we will write Q1. Q1 on B. Q1 on B, we are getting Q0. So here we will write Q0. Now we have to write the output associated with Q1. So the output associated with Q1 is 1. So here we will write 1. I hope you find the construction of the transition table of a Moore machine very simple. So this is the transition table and the transition diagram of a Moore machine. Now let's talk about the six-tuple representation of a Moore machine. Six-tuple representation of a Moore machine is exactly same as the six-tuple representation of a Mealy machine. There is only one difference, and that difference comes with the lambda, that is output function. So Q is the set of states, sigma is the input alphabet, which is the set of input symbols, capital delta is the output alphabet, which is the set of output symbols. Transition function is same as the transition function of a DFA and of a mealy machine. Now comes the output function lambda. Output function equation is lambda, Q is giving us delta. In case of mealy machines, here we were having Q cross sigma is giving us delta. But in case of Moore machine, only Q is giving us delta. Why? Because in case of mealy machine, the present state and the input symbol both were determining the output symbol. But in case of Moore machine, only the present state will determine the output symbol. That is why this is the equation of output function in case of Moore machine. Now Q0 is the initial state of our Moore machine. So this is the six-tuple representation of the Moore machine. Now let's find out the values of each of these elements one by one with respect to this particular transition diagram of a Moore machine. First, we will find out the values of Q, sigma, capital delta and Q0. Q is equal to Q0, Q1. We have only two states Q0 and Q1. That is why the value of Q is Q0, Q1. Sigma, which is the set of input symbols. We have only two input symbols A and B. So sigma is the set of A and B. Output symbols capital delta is equal to 0, 1. We have only two output symbols 0 and 1. So the set of output symbols will be 0, 1. Q0 is the initial state and the initial state for this particular diagram is Q0 only. So here we will write Q0. Now let's calculate the values of transition function delta. So these are the values and you can clearly see Q0 on A gives Q0, Q0 on A gives Q0, Q0 on B gives Q1, Q0 on B gives Q1, Q1 on A gives Q1, Q1 on A gives Q1 and Q1 on B gives Q0. So Q1 on B gives Q0. This is the transition function. Now let's find out the values of output function lambda. Lambda Q0 is giving us 0 and lambda Q1 is giving us 1. That means Q0 is associated with 0 and Q1 is associated with 1. As you can see, Q0 is giving the output 0 and Q1 is giving the output 1. Because in case of Moore machine, only the present state will determine the output symbol. That is why this is the way of representation of an output function in case of Moore machines. I hope you are clear with this topic now. Now let's proceed further. Input to output generation. In this particular subtopic, we will understand how to translate or transduce an input string into its corresponding output sequence in case of Moore machines. So this is the transition diagram of Moore machine and this is the input string that I have taken, A, B, B, A. And now with the help of Moore machine, we will translate this particular input string into its corresponding output sequence. Because Moore machine is also a finite state machine with output. That means it also generates the output sequence corresponding to the given input string, like Mealy machine. So we will start with the initial state, that is Q0. So first of all, we will write the initial state, that is Q0. As you can see, the state Q0 is associated with the output 0. So Q0 is giving the output 0. So here we will write 0. If you observe, we have written the first output symbol without even processing the first input symbol. In case of Mealy machine, without processing the input symbol, we were not able to write the output symbol. But here, the initial state itself is associated with a particular output symbol which is 0. That is why, before even processing the first input symbol, we have written the first output symbol, that is 0. Because Q0 is associated with 0. Q0 is associated with 0. Now we will talk about the first input symbol, which is A. So Q0 on getting the first input symbol, which is A. Q0 on A will give us Q0. So the next state is Q0. And as you can see, Q0 is associated with 0. So here we will write the output 0. Now the next input symbol is B. Q0 on B. So Q0 on B. Q0 on getting input symbol B, the next state is Q1. So here we will write Q1. And as you can see, Q1 is associated with the output 1. So here we will write 1 as the output symbol. Now the next input symbol is B. So Q1 on getting B. Q1 on getting B, the next state is Q0, which is associated with 0. So here we will write Q0, which is associated with output symbol 0. Now the last input symbol is A. So Q0 on getting A. Q0 on getting A, the next state is Q0. So here we will write Q0. And as you can see, Q0 is associated with 0. So we will write the output symbol 0. Finally, we are getting the output sequence as 0, 0, 1, 0, 0. So in case of Moore machine, for the input string A, B, B, A, the output sequence is 0, 0, 1, 0, 0. And if you carefully observe, you will find on getting the input of length n in Moore machine, the output is of the length n plus 1. So here the length of input string is 4, 1, 2, 3, 4. And the output string length is 1, 2, 3, 4, 5. That means the length of output string is 1 plus the length of input string. So if the length of input string is n, then the length of output string is n plus 1. In case of Mealy machines, if the length of input string is n, then the length of output string is also n. But it is n plus 1 in case of Moore machine. So I hope input to output generation in case of Moore machine is now clear to you. In this way, we are done with our topic, Moore machine. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.